Hello, AP Stats students. Mr. Hazelhorse coming to you live from Huntsville, Texas, actually, today. And here's your one video that you're going to have to watch for Chapter 10. And what we're basically going to look at here are just the basic ideas behind a confidence interval, which is going to be the topic and concept that we cover here in Chapter 10. And so you're going to see a lot of terms, a lot of big ideas, but we're not going to see any example problems today. We'll get to those in class. But again, the whole idea here is just to give you some of the basics behind a confidence interval, which is going to be a very important concept that we cover here in AP Stats. So as we get into Chapter 10 today, I want to remind you of this concept of statistical inference. This is what we're going to spend the rest of time this semester and during the class covering. And when we think about statistical inference, the whole idea here again is that we're going to try and draw some conclusion about a population from sample data. Now, it's important for us to understand the whole idea behind statistics. If we could know things or find out things about a population easily, there would be no point for statistics. But when we think about statistical inference, again, the idea is that we're going to deal with unknown facts about a population. And those are things that we're hoping to be able to confidently estimate or to be able to confidently determine. And what we're going to base all of our decisions on are things that we understand about a sample. And so we're going to work with statistics with the idea of estimating a parameter. All right? And as we begin to move into this concept of statistical inference, there are the two most common methods of statistical inference are confidence intervals and significance tests. So we're going to deal with confidence intervals here in Chapter 10. We'll deal with significance tests in Chapter 11. And then the rest of the class will kind of continue to build off of these two topics. And what's really important to understand is that both of these are based on the information that we just covered here in Chapter 9 on sampling distributions. So let's go back and review some of the important information about sampling distributions real quick. So hopefully you recognize this chart. We've seen this before. You guys filled this out in Chapter 9. But again, this is the important information that we want to take away from Chapter 9, and we're going to use in all future chapters here in AP Stats. And so again, just like in Chapter 9, we're going to focus on the two most common types of statistics. We're going to deal with proportions, and we're going to deal with sample means. So you can think of it as we're going to use p hat, and we're going to use x bar to create our sampling distributions, just like we did in Chapter 9. And so the conditions that we learned from Chapter 9 for both proportions and means are going to carry forward with us. The information that we know about the center of a sampling distribution, where the mean falls, will be important, and the information that we learned about the spread or the standard deviation will be important. And I want you to remember that fact that we kind of hammered on time and time again in Chapter 9. As the sample size increases, the variability or the standard deviation will decrease. And that will be really important to us here, not only in Chapters 10 with confidence intervals, but also with Chapter 11 and significance tests. So when we talk about confidence intervals, what are we dealing with? Well, it's really a very simple concept. From now on, when you hear the term confidence interval, what I want you to think of is it's an estimate. That's really exactly what it is. Again, we're trying to learn something about the population. So we may want to estimate what the true population mean is. We may want to estimate what the true population proportion is, those parameters. But the only way to truly know those parameters is to study the entire population. And again, we know from a statistical standpoint that just doesn't make much sense. We don't have the resources available, the time available to do that. So again, from a statistical standpoint, we're not going to work with the parameters, but we're going to use a statistic to estimate that parameter. And so a confidence interval is just simply found by using this formula. We're going to take a statistic and we're going to add or subtract to it some margin of error that will give us this interval in which we will be confident that the true population parameter may fall. Okay? So the reason why we're going to add or subtract some margin of error is simply because of what we already understand about statistics. When you think back to Chapter 9 as we studied sampling distributions, we don't expect every statistic to be exactly equal to the population mean or the population proportion, right? We know that x bar is not going to be equal to mu. But we do know if we take a whole bunch of samples and create a sampling distribution, the average of all of those will be the population parameter. Now, in statistics, we're not going to deal with a whole bunch of samples. We're going to deal with one. And so that's where this idea of a margin of error comes into play. Now, in your gold packet, the concept of a margin of error gets broken down even a little bit further. All right, and again, this formula is in your gold packet. And we're going to talk about these concepts here today. So critical value, let's hold off on that one here for just a moment. But let's start out with the standard deviation of this statistic. All right, again, this is all in your gold packet. So the standard deviation of the statistics, well, that's just the standard deviation of the sampling distribution. And so we look at these formulas down here that show up in your gold packet. We've seen those before. We've used those same formulas in Chapter 9 in a sampling distribution, and those are going to carry forward here again. All right. Now, when we say statistic at the beginning of the formula, that would be what our sample mean is. If I'm going to estimate the population mean, the statistic will be the sample mean. If I'm going to estimate the population proportion, I would be using the sample proportion, or p-hat. And then again, we're going to add or subtract to that value some margin of error because of the variability that takes place within all samples. All right? So some terms here next that we need to be aware of as we work with confidence intervals. So the first term that you need to be aware of is the idea of a confidence level, and we're going to see this abbreviated with the letter C. And what this represents is the probability that the interval will capture the true parameter value in repeated samples. And what I want you to think of, this is the success rate of our method, not the success rate of a specific interval that we create, but we have confidence in our intervals because, again, of what we know about sampling distributions. And so when you look at the diagram on this page, we have a sampling distribution of X bar. And again, we know that the true population mean is going to fall in the center of this distribution. And our goal is to try and come up with what that value actually is. And so what you see underneath this is a bunch of different confidence intervals. All the dots that are in between, those are representing the sample means. Okay? So if we took a sample from this population and we found the average, right, some of those sample means are going to be very close to the true mean, and we can see that with some of those here, right? We see that with this value down here, or this value, or the value at the top, right? All of those are very close. But we don't know that because we don't truly know what the population mean is. And some of our values are a little further off, and again, that's sampling variability. But if we look, if the arrows that are surrounding these sample means, those are representing a confidence interval. So we've taken this statistic, the point in the middle, and we've added and subtracted to it some margin of error, and that gives us this window that we're looking. And if you look down this example, all but one of our interval estimates contain the true value of the mean. Why is that? Because, again, of what we know about a sampling distribution. All right, we know, we can be confident that as we create these confidence intervals, that a majority of the time, they're actually going to include the mean of the population. Not always. Again, we see that here. We have one confidence interval that doesn't include the true population mean. But again, it's a statistic. It's not going to be perfect. All right, so a confidence level will be very important. All right, and we'll talk more about this here in another slide here in just a moment. Now, the next term that I want you to be aware of is this idea of a critical value. All right, and the critical value is essentially just a z-score, but it's a specific z-score. It's a z-score that cuts off a specific percent of our normal distribution. So when you look at this diagram here, our probability that we see down here being 0.8, well, this would be the same as saying I have 80% confidence. And so what we're going to do is we're going to create a confidence interval that contains 80%, the middle 80% of the normal distribution. And so to do that, we need z-scores that cut off that middle 80%. And I'll show you how to actually find these here in the next couple of days, but it would take a z-score of 1.28. We would have to be 1.28 standard deviations above the mean and 1.28 standard deviations below the mean to cut off the middle 80% of the curve. And so that critical value helps determine our margin of error and helps determine how wide our confidence interval will be. And so these are some important z-scores that I would encourage you to write in your gold packet, because these are going to be the 3 confidence levels that we deal with the most. All right, we'll deal with a 90%, 95, and 99%. Okay, and so the critical values that it takes to cut those off are 1.645, 1.96, and 2.576. So when we look at these z-scores, these critical values, what I want you to understand, again, is that's telling us how many standard deviations from the mean we need to move to include that percent of our normal distribution. And that percent of our normal distribution is representing the confidence level. So if we move 1.645 standard deviations above the mean and below the mean, we're going to create an area that represents the middle 90% of our normal distribution. And so that's why we say we have 90% confidence. All right. 95%, we need to move 1.96 standard deviations away, pretty similar to our 68, 95, 99.7 rule. And 99%, we need to move 2.576 standard deviations away. Now, if we wanted to have 100% confidence, because this normal distribution extends technically forever in both the left and right, we would have to say, okay, we estimate that it's somewhere between a negative infinity and a positive infinity. Okay? Well, that doesn't make much sense, right? Why are we going to estimate something and have that large of a range? And so we want to get it more towards the middle. All right, but a good thing, again, what we know about the normal distribution is most of the values center in the middle. So we don't have to move very many standard deviations away from the mean to include a majority of the normal distribution. All right, so 2 big terms that I want you to take away from today. Again, the confidence level, which is representing the percent of area that we're cutting off. And we want to think of that as the success rate of our method, and the critical value, which is just the z-score that we need to create that confidence level. Okay? Now, the part that we're going to focus in on the most as we create these confidence intervals will be the margin of error. And remember from your gold packet, the margin of error is just represented by taking the critical value, that z-score, and multiplying it by the standard deviation of the statistic. And it's really important in statistics that we'll want to try and control this margin of error. And there are certain things that we have control over as statisticians that can influence whether our margin of error is large or small. And it will probably make sense to you here, but ultimately what we want is a small margin of error. The smaller our margin of error, the more accurate our interval estimate will be. And so when we think about how we can control that as a statistician, there's really only 2 things that we have control over. All right, we can determine what the critical value is. Now, what we have to understand, if we use a smaller z-score, a smaller critical value, that's also going to mean a lower level of confidence. All right, so there's kind of a double-edged sword here. All right, low margin of error is good, but we don't want low confidence, okay? If we think of a normal distribution, and I created a 50% confidence interval, well, if we say we're 50% confident, that really means it's like flipping a coin, either your estimate is right or not. But what we want is an estimate that's more likely to be right. We want higher confidence. Now, the other thing that we have control over, again, is the standard deviation of the statistic. Because, again, we know from Chapter 9 that by increasing the sample size, that will decrease the variability. So if we decrease the variability and we squeeze more of the normal distribution towards the center, well, that's going to reduce our margin of error as well. And so as we move forward and work with confidence intervals, I want you to keep those 2 things in mind, all right? If we're not happy with our margin of error, we really only have 2 choices as statisticians. We can decrease our critical value, but then we have the issue of having lower confidence, or we can increase our sample size, which may mean more work, all right? May mean we need to use more money to do that, to collect more data. Neither one of these is perfect, but those are the 2 options that we have. Now, the last thing that I want to introduce you to is what we're going to refer to as the Inference Toolbox. A lot of times in directions on your quizzes, tests, worksheets, that sort of thing, I'm going to ask you to use the Inference Toolbox to create a confidence interval. And when I do that, I'm going to expect to see 4 things. And so I want to introduce these to you today. You're not really going to use them to work an example problem, but as we get going here over the rest of Chapter 10, I just want you to know that these are the things that I expect. And we're going to see this same inference toolbox carry forward with us into Chapter 11. The only thing we'll really end up changing will be the calculations and the interpretation step. So the first thing I'm going to expect to see you do is to talk about the parameter that we are trying to estimate. All right, what are we trying to find out about? Let's state that from the beginning. Okay. Second is conditions, and you're going to see a lot of these conditions to be the same as what we used in Chapter 9 with the addition of the simple random sample. So the new condition is that we're going to expect our data to come from a simple random sample. We want to avoid any bias that may be intentionally put in based on the methods that we use. So we know if we use a simple random sample, that's going to be our best way to avoid those types of bias. Number 2, we're going to want to base things on a normal distribution again. All right, we want to use these sampling distributions that we talked about in Chapter 9. So we need to make sure that those conditions of normality are met. And then finally, the same condition we used before about assuming that our sample size was, our population was 10 times larger than our sample. What we refer to that here in Chapter 10 is we want independence. Okay. Number 3, you're going to have your calculations, which just simply comes down to finding your estimate, your statistic, and you're going to add or subtract some margin of error. And then last but not least will be our interpretation. All right, we're going to say something along the lines of we are blank % confident that the true mean or proportion, and then go back to your parameter, is between blank and blank. And the blank and blank are going to come from the calculation step up above. And this is going to be a really simple process and something that by the end of Chapter 10 you're going to be very comfortable working through, and we'll use this in all the examples that we do here in the rest of Chapter 10. All right, so Inference Toolbox, 4 steps. Number 1, parameter. 2, conditions. 3, calculations. 4, interpretation. And this will be the same toolbox that we use in Chapter 11 and the chapters that follow after as well. Okay? So as always, I just want to remind you to complete the form below, mark any questions or kind of terms or concepts that you heard about today in the comments box below. And again, I just want to remind you, this is kind of a big concept topic right now, and I was just going through the big ideas behind confidence intervals, the terminology, but we'll get down to some nuts and bolts of how to actually apply these in some actual problems here over the next couple of days once we gather back together next week. And so some of the big questions that you may have, we'll probably address those as we begin to work through some problems down the road, but still I want you to mark those questions down in the form below. And I hope everybody has a great day, and I'll see you on Monday.
Made with Doodlecast Pro.